Welcome to this video. Today I'm going to show you how to design volute for centrifugal pump impeller. This centrifugal pump impeller we have designed in previous video tutorials. You can find it on my channel. It's called OpenFOAM plus FreeCAD design and simulation of impeller pump, centrifugal pump. And today we will take this impeller geometry and create the volute for this for future CFD simulation in OpenFOAM and estimation of head of a pump, which was designed using the design software and estimation in CFD. So the general input parameters for pump we have here. It's a volume flow rate 150, head of pump 100, rotation speed 3000, and this general performance parameters. And here we have the output of report of output, which we have used for design of impeller. So today we have to calculate the general dimension of volute. We will be using the very simple method for calculation of volute based on mean velocity, outlet velocity here. This velocity we can calculate using this formula, where the K out is coefficient head, here H is head of a pump, and here we can to calculate this coefficient using specific speed of a pump. It's a very simple expressions. Specific speed of a pump we have here. We paste it here, calculate the K out, calculate the velocity for this section of volute. Recommend this also. This is a recommendation from literature, and after that we can calculate the area of this section of volute. This is just a general area which we have to define in our section, and type of section can be the circle or a box. Here we will be using the box approach when we will create the 2D sketch of volute in FreeCAD and just extrude this CFD domain for next future CFD simulation and merge it with our impeller. Okay, so the area of outlet for this example case, we have here the volume flow rate 150 divided by this value. We convert hours to seconds here, and we will get meters power 3 per second. And after that we divided it by velocity at the outlet, this value. And after that we will get the value of area. I converted to millimeters power 2 area. We have 2000 millimeters power 2. And after that we have go to FreeCAD and perform creation of 3D model of this volute and try to make this value of area. And for this section we will just divided this all area to the, here we have the half of this area, here we have the 1/4 this area, 25%, and we will try to create it in FreeCAD. So let's open the FreeCAD, and I prepare the geometry of impeller from previous video tutorial. I just to make import it, impeller blades. You can download it or create it from previous video tutorial. I will set a link below to where you can download this Impella CFD domain with blades. Just import it to FreeCAD and you will get this Impella here. Okay, it's a CFD domain, and we will be using this surface for connect our CFD domain of a Volute. It is data region with a rotation region is Impella. So let's go to part design workbench. Here let's make this operation create body, and we have here our body, and let's run the creation of 2D sketch of our volute in 2D. We will be using the YZ plane here. Okay, and now let's create the circle. It will be the internal circle of volute. We have to find the dimension of this external diameter of Impella. We can just try to import it, but we cannot because we have this body, external body here. So it means that we have to go to part workbench or sketcher workbench, and here we have to in sketcher workbench create the 2D sketch YZ plan, use it again, and let's make export of our external edge of diameter, and let's find the radius of this value. You will get this radius. If you will want to find the diameter, you can also choose this circle and find the diameter, set it here. You will get this value. This is an external of our CFD domain part, and now we have to, for example, to write it here. For example, the 3 will be 7 millimeters. And just save it here. And after that, let's just close the sketch. We will not use this anymore. We can delete it, and let's go to body workbench, and it automatically change the part design workbench here, and let's go to sketcher, and here for the sketcher we can set the diameter and paste this value of the 3. Okay, and now we have a fixed value of our external diameter here. After that, we have to find the width of our Impella here. We can just close the sketch. You can choose, for example, this surface, and you will get here for this face the X constant value. It means that we have the constant value in X direction in relative of this X direction. If you will choose this, for example, choose this, and you can see the value is 40, and we can choose this surface. You will get 58, and we can calculate the difference between them. Let's write it here. V3, V2, 58 minus 40. 58 minus, let's check it again, minus 40, yes. Okay, and just open calculator, click it here, for example, and you will find this width. Also, you can use the Python here, native Python. I will show you how you can view the Python console, for example. And for example, for this Python console, we can paste different simple commands like 1 plus 2. You will get the results, for example 58 for our case, and you will get the difference here. You can use it like a simple calculator, of course. So after that, let's create the width of this for our CFD domain. We have to use this value for connection, this part and this external face, if we will extrude this surface in X direction. So let's I think we just can multiply this value and get the bit3 value. It will be a width of our volute. But for this we have to define the radial maximum value of our volute. It means if we want to make smaller widths, we have to increase the radial direction, because we have to define this constant value of a out area. So if we will be using the box, we have to just multiply this radial direction of volute size and this meridional section of volute size, the width of this volute. Okay, let's use this sketch and go to edit sketch, try to make a simple prediction how will be looks our radial line, and we'll try to calculate the width and find the right aspect ratio between them. Okay, after, let's just paste here the line. We have to make some bigger line because we want to have here something like a gap for our volute. Okay, so let's go to left view. We can make here it and merge it point. Let's go to this view because we have to work in a right view here for these points, and let's try to make some radial widths. Make some correction here. Maybe we can just paste this point position here, and let's just define this vertical length, for example 100. Let's try it, and now we can just divide this area. I will save it to variable to FreeCAD Python. I will use a out, and I just define this variable here. It's a very basics of Python, and use this value, and here we have the defined value of this, and if you will just paste this variable here name, you will get this value. And it means that we can to use this a out divided by 2, for example, and you will get this divided value because this variable include our value 2000 millimeters per second, millimeters power 2. Okay, say so a out, and we have to divide it a out by 100, and you will get the width, recommendation width for constant value of this area. I think it will be the very small width. We can to increase it, and we can to make a smaller value of this. I think it can be 15. Try it. It will be this value, but I want to increase it 75. I think it will be the something optimal value. And a out divided by 75, and you will get this width of extrusion for our volute. Okay, so now let's use this value, and if we will have a constant width for all this circle, we can to create these lines for this position, this and this position, for example. It means that here we have the maximum value area, it volute outlet. Let's create the line also here, and here. So, but before it, we have to change the mode working of the sketcher. We can, I will show you what does it mean. This is toggle driven reference constraint. Let's toggle it. You can also find it icon here. Toggle. No, this is not what I want. I want a toggle construction geometry. Yes. Okay, let's choose the toggle construction, this icon. You can to change the mode of working of your menu and your tools. It means if you will create this line and you will try to make extrusion, these blue lines will be ignored of general sketcher of white lines. If you will create the closer white line sketch, you will be using only white lines for 3D modeling. Blue lines will be ignored by 3D model creator. So let's use this line and lines for creation. We have connected it with axis, and we have to define the length of this. You can use this command, and we have to set it here, and let's just paste here the right length. It means we have to multiply 75 to 3 and divide it by 4, and you will get this value. We can to set it, Ctrl C, copy, and try to paste it here. click OK, and you will get your right lens here. Also, we can define here. You can define the sum gap between your external part here and the volute part. Let's create this right, and you will get this gap. Okay, and let's define this gap for this also. Okay, after that, let's create one else line here for this axis. Here we have to also define the lens, and it will be the half of this general area. Let's divide it by 2, copy it, Ctrl+C, Ctrl+V, and paste it here. And let's paste here this value of position. And the last one will be this line, construction line, and let's set the length of this line, the random value. That works. Let's delete it and try again. No, I think, yeah, I paste Ctrl+Z. Okay, let's try again. It's not right. We have some troubles with this. I will create it here. I don't know what happened here. I will set the length, random length. This I will divide by 4, and I will get the right length, radial length of our volute. And after that we can connect, for example, this point with this line, paste it, and you will get this line here, this connection, this point on this axis line. Let's choose these 2 points and set the position in horizontal right position here. Okay. After that, you have to create the line which is define our radial volute position, and for this we can increase this value position for this line, and we will create will show you what I mean. I will create here the point, and for this point I will set the position, and this point I want to connect with this point. I will just close the sketch, and I think I will just hide this 3D model, hide item, but no, it's not what I want. Just press space button on keyboard. Let's go to Sketcher, and you will see here our parameters of our volute, and this point we have, and we want to connect this point, this external points. So let's change the toggle construction geometry, return the normal view. Maybe I think we can use the arc by 3 points. Let's try it. Okay, for this and this line you will get here, and let's use this and this line. So it we have some faults with this. Let's try again this point, and this point, but it's not normal. Let's just choose here arc by 3 point again. Maybe we can do 3 rim point here and delete one what we don't need it. Okay, and after that we can use the stream operation here, and you have this part of circle and this part. Okay, it's looking good, looks good. And here we can make a connection for our this line and this volute part. Okay, let's use for this arc by 3 point we can use. And we can paste here something like a condition. It will be something like tangential condition. Let's paste it here, and we have the very smooth part here because we have this condition tangency. Okay, so now it looks good view, but we have to increase this D3 because we will I will show you what we want to make in this next step. I just to increase this, I think a couple of millimeters, maybe this value, maybe more. And here maybe not much more. Okay, and let's close it, sketch, and you will get this to the sketch of our volute. So now we have to paste here the paste here the D2, and if you remember, we have to make it using this length of our volute, 75 millimeters, and divide our value of area outlet by this a out, how you remember, and we can divide it by this, and you can use this width for extrusion. Use the sketch. Let's make a path, paste it here, press OK, and you will get your Volute. Yeah, and after that we can to increase this, make this extrusion here, for make an outlet for our flow. Let's choose this surface and let's go to this part. Let's create the sketch here. We have to create the rectangle, but we cannot to connect these points with this geometry. So let's delete it. I will show you how. Look at simple. You can just to paste here point using this tool. It create an edge or another geometries like points from external geometry to your sketcher, and after that you can to connect here these points and you will get the rectangle which connected with your external geometry. So let's close it, and after that you can to make a path operation for this. For example, paste here something like this, and you will get here some value of your rectangle. Let's make the refine true. It will delete these lines from your geometry. And after that I want to create some diffuser, because outlet will be something like a circle. We have to create the sketch, but we have to connect the sketch with something in some place here. It means that we have to create the datum plane, define for example this surface, and for this surface we have to set the some position, but this position not true. We have to use not axis. Let's edit datum. We have to use another direction. Let's try this. No, this is not what we want. Let's try this, and this is correct. Z is a perpendicular of a plane. This meaning in part design workbench. Okay, so let's increase it. I think something like here to paste this datum plane, and for this datum plane we have to create a sketch. Yeah, we have also to export from external geometry these lines, and for example I want to create the center of this rectangle, and for this I will use this trick. I will change the toggle construction geometry mode and create the two diagonals here and here, and after that again for example use this not working like I want. I just to trim the part, use the trim and find this point here. I just to delete this part of line. I will get this intersection of center of your rectangle. So let's let's change the mode of working for your toggle construction geometry, and let's go to creation of circle here, and let's set here some diameter for your, I think we can use this value of your for your outlet from your volute. And after that we have close the sketch, go to this face and create here again a rectangle. Let's import these 2 points, and for these 2 points let's create the rectangle geometry. Okay, and after that let's close the sketch, and we have to try to use the part design tool for connection, make the connection between these 2 different sketches, this sketch and this sketch. Let's try this in the sketch, and here we can use something like a loft operation. Okay, just try click OK, and part design workbench create a good shape of this. You can hide this, just choose it here and press space button on keyboard, and you will get a very high quality shape for your diffuser here. This is a volute for your CFD simulation, but we have to make the connection between impeller position and width here. Make some step part here, and let's try this. I think the one else part, I want to create some cylinder here, because we have the diffuser, and if you will try to calculate it, you can make some troubles with simulation, because we can get here the return flows. So it means that we have to increase this in cylinder part. Let's use this surface, create sketch here. Let's import this part of shape and create a circle, and let's create a path operation for this circle, and let's make this some cylinder part here. Then we can also increase the cylindrical part. For this we can increase it, for example, to 1000, maybe 150. Okay, I think we can save a project. Volute called it, because if FreeCAD is crash, you can waste your model. Okay, after that let's try to make here the connection between this and this part. Let's but before it we also have to make a right position for your volute and impeller. Let's try to change the position of your volute. You can change the placement position. In here we have the X direction is a rotation axis also, and you can change the position and X direction of your model. And also you can find this right position. If you will just your center position, you can to use this difference in axis for axis. If you will choose this face, you have here the value of your x position. Let's check it. It's 40 in x direction, and for this part you have the 58. 8 minus 40. Let's divide it by 2. You will find, if you will plus 40 plus 9, you will get the center position here for your case. And let's check the position for your, let's save it to your imp center variable. Let's check, and let's find position for your volute now. It will be 30. It will be this value minus 30 divided by 2, and you will get this position now. And we can to find the difference between this 4 minus imp center. Maybe try to check what we have the value. Yes, this value, and the difference will be 34.6. We have to increase it plus 34.6, and you will get a right central position for your model. But it will be equal for your this part. Let's to change the position for your wallet again, and we will paste it something like bigger to half of your length for your impeller. The impeller length, half of length impeller will be this divided by 2, it will be the 9, and plus try this. Sorry, it's the not. I will change the lens of our. I will change this lens. Okay, I will just copy this value. It's not bad. So let's paste 115, and we have to change, of course, the body position here. If for this we have this value, we have to minus this point, minus this, and you will get 40 this, and let's try this value, and plus here to 30, of course. Okay, and we can get the sum not right position. We will try to change -9, -9. Maybe just a paste here, a right. I think we have to paste it here. And for this we have to make -9, and you will get the right central position here. We have to change the position of our volute, but before it, how can you see, we have the trouble with position of our volute for your impeller, because rotation of impeller to this direction and flow will going out to this side, but we have the volute is mirrored for your flow direction. So it means that we have to make to rotate our volute around that direction, around that axis. So let's choose the angle, choose the body in 3, and for that axis we have to make this direction. And now we have the right direction of the volute for our flow from impeller here. Okay, so it's important for centrifugal pumps. And now we have to change the position for our impeller and volute and set the right position for our these surfaces. But before it, let's create another step for our volute here, because we have to connect these two surfaces for your this and this for your interface for CV simulation. So let's go to part design workbench here, and let's create to the sketch. You can choose the XZ plane, and for XZ plane we have to paste to our sketch this right position of our volute, and let's close the sketch and let's hide the pad. After that, let's go to edit value, but we have again our model here of a volute. Go here, hide it here without closing of the sketch, and after that let's create here the sum step. Okay, for this let's use the additional support lines, change the toggle instruction geometry here, let's set here, and after that let's create the point, and for this point we will set to center for this line. Let's choose this point, and this, and click this symmetry. After try and change the point position, you will get this center right position here. Okay, and after that let's go to normal construction geometry mode, and let's try to create a rectangle here. And this rectangle we will set, but it's some trouble with this. Let's create the rectangle in this view, I think. After remove, you can do update and delete some what we don't need, some construction lines, for example. Let's try again, create here and delete this, and just go change the position of our rectangle here, and let's just to make a connection between this point and this line, this condition. And now we have the line on this line, this point on this line, and here also for this point position. After that, let's set here the length for our surface here. This surface length, we calculated it 18. Let's set it here. And change 18, set in here. And now we have to choose the right position in D2 for this free position. We have this value of diameter. We have to choose this to, for example, you have to choose this point and this axis line and set the vertical position, and it will be the half of this value. Let's copy it and divide it by 2, and you will get some right position. After that, we have to, for this and this line, you have to set the right 9 length. You will get the right position of this rectangle. And after that, just close a sketch, show us the volute, and try to make a revolution. Okay, click OK, but here we have some trouble with sketch. We cannot to connect this model with the sketch because we have the changes of position here. If you will set here 0, no, it have to work. Let's choose the sketch again and try to make the revolution. And here we have to use another axis. Yeah, it works now. Oh, okay, yeah, we don't have some troubles, it works. I just have to use the right axis for this operation and for this revolution. Let's click the refine true. And now we can to set the right position for our impeller and for our volute in X direction. So for this, let's calculate what position we have for our impeller. Let's choose this surface. You will get 40 millimeters. For example, if I will just show this line, go to this information for our face, it will be 40 millimeters. And we have to go this to 0. Let's go to position and minus 40. Okay, and for this line we have this minus, okay, I will choose this here, minus 23.4. And let's change the position for this surface. 3.4. Next direction 3.4. And how can you see? We have the right connection between the rotor region and stator region, and we have our volute geometry, and here we have this right connection here also. And after that you can try you have to save this and these models in step format, and the next step will be creation of the mesh for this domain, CFD domains, for future CFD simulation in OpenFOAM. Thank you for watching, subscribe to the channel, goodbye.